Alright, now in this video, I'm going to talk about the Chatelier principle, but turns out the temperature. Alright, now first, okay, I know that I did not have time to go over in class a lot, so let me just explain detailedly here. Now, endothermic, endo meaning enter, right? E-N-T-R, enter, and thermic meaning energy. So it means the energy enters in the system. Okay, in the system. Energy enter in the system. And then exo meaning exit. So energy exit the system. That means energy leaving. Okay. Now there are three concepts for each system. So endothermic meaning you absorb heat as reactant. Okay. And exo meaning you release heat as product. Right? Because you're releasing heat out as a product. And number two, you will see kilojoule or energy on the left-hand side of the equilibrium because you take energy, you take heat as reactant. So they must be shown on the left-hand side of the equilibrium because it's reactant, because you're taking in. And if the exothermic, you will see energy, kilojoule will be on the right-hand side of the equilibrium because you release energy as product. So it must be on the right-hand side of the equilibrium. And then the delta H meaning enthalpy. Enthalpy. Okay, you don't have to know this until like AP Chem, but enthalpy is positive in endothermic because you're taking energy in, so then your delta H will be positive because you're taking energy in. And then when you have exothermic, your delta H will be negative because you are losing heat, so you become negative. Okay, now here will be increasing temperature, right, in the two system, decreasing temperature in the two system. Now, anytime when I say favorite, meaning happy, will go towards the product. Every time when I say not favorite, that means I'm not happy, will go back to reactant. And then the reason thing, right, is right here. So temperature go up in the endo will be favorable. And then temperature go up in exo will be not favorable. And same thing for temperature go down in endo will be not favorable. Temperature go down in exo will be not favorable. So you will not need to memorize that, but I'm going to show you how to use the concept here. Okay, you don't need to memorize that because it's just like make up story. Now, first of all, at the back of the table, I need to fix the equilibrium. So this is not one arrow, will be equilibrium sign. So make sure you fix that. Okay, so based on what we have here, the definition, there are four kinds of the system, and then four kinds of the system on the worksheet as well as on the table. So they're different situation. Okay, so now first of all, you're gonna read, oh, delta H is negative 96 kilojoule. And you see that there's no plus sign on here. That means my delta H is not part of the energy. So delta H is negative 96 kilojoule. Okay, so this is the exo endo. This will be exo. Why? Because my delta H is negative. Okay, my delta H is negative. That will be exo. Now, number two, you see that this is the energy, the kilojoule is part of the reaction because you see the plus sign, and this is on the left-hand side of the arrow. So that means it is a reactant. If it's a reactant, that means you're taking energy in. So this is a endothermic because you're taking energy in based on the fact that the kilojoule is on the left-hand side of the arrow. So they're all, the reason thing, like they're all on the back here, right? They're on here. Now, number three, you see that the 96 kilojoule is part of the equation here. So it is exothermic because it's on the right-hand side of the arrow. That means it's releasing as the product. So this is an exo because the kilojoule is on the right-hand side of the equilibrium. Okay. And the last thing is, this delta H is not part of the energy. You see, there's no plus sign here. But this delta H is positive 96 kilojoule. So we're actually taking in energy. That's why your delta H becomes positive. So this is endothermic because your delta H is positive. Right? So you have to recognize this false situation before you start. Okay. Now here, I'm using the check mark for favorable, meaning you're happy, and X for not favorable, that means you're not happy. Okay, now you're in an endothermic system, your exothermic system, that means I am currently in this system. Okay, I'm currently in endo, I'm currently in exo. This is where I am now. So if I'm endothermic system, that means energy is endo, right? Entering, so energy is coming in. So if energy coming in, now energy meaning close. So if energy is coming in, meaning I want to put more clothes. I want to put more clothes because I'm in this system. Endothermic meaning energy is coming in. Heat is coming in. That means I want to put clothes on. Exothermic, exo meaning exit, so energy is leaving out. So when heat is leaving, that means I want to take away my clothes. I want to take away my clothes. This is where I am right now. Now, when you're changing my temperature, these two are changes. Okay, they are changes. You're changing my temperature now. Okay, so if you increase the temperature, that means you now want to do something onto me. You change my system. So if you increase the temperature, that means you want to give close to me. Because you increase temperature, that means you give more and more clothes. If you decrease the temperature, that means you take away my clothes. That's the changes you want to do it. So we get a false situation, okay? Now, if we are endothermic system, that means heat is coming in. That means I want to put clothes on. If I want to put clothes on, if you increase my temperature, that means you want to give me clothes. So they both want to give me clothes. I put clothes on, give me clothes. They both matching. So that means I am happy. I'm favorable. If I'm happy, I want to shift my equilibrium to product. Because they both want to put clothes on. They match. Put clothes on, give me clothes. They match. Now, if I'm endothermic system again, that means I want to have heat coming in. I want to put clothes on. And if you decrease my temperature, that means you take away my clothes. So this is want to put clothes on. This is take away my clothes. So I'm not going to be happy, not favorable. If not happy, I will go back to reactant. Because this is take away clothes. This is want to put clothes on. They're not matching. Now, if I'm an exothermic, that means I want to I'm in the system that heat is leaving. That means I want to take away my clothes. I want to take away my clothes because heat is leaving. So if you increase the temperature, that means you want to give me clothes. Now, I want to take away clothes, but you give me clothes because you give me temperature. So I'm not going to be happy because I want to take away my clothes, but you give me clothes. So I'm not going to be happy, not favorable. Then I want to go to reactant. Right? Now, exothermic system, I want to have my heat leaving. That means I want to take away my clothes. I want to take away my clothes. Now, if you decrease my temperature, that means you also want to take away my clothes. Oh, take away my clothes, take away my clothes. I'm happy because they match. So if I'm happy, I want to go to product. All right. So then now I can go back to this worksheet to work it out. All right. So first of all, there are a couple of things you want to decide. Okay, now you want to decide what kind of system it is. So before the worksheet, I already decided that this is a gas system. Right, this is a gas system. Number one, it is a gas system. Okay, now number two, what kind of endo or exo it is. So we base on what we just learned from here. Okay, what we just learned from here. Oh, we look it up. Oh, this question, 92 kilojoule is part of the reaction. Basically, see the plus sign, and it's on the right-hand side of the equation. So this is a exothermic because the kilojoule is on right of arrow. This is exothermic because the kilojoule is on the right-hand side of the arrow. That means that I want to release heat as energy. Okay? So if we decide what kind of system, we look up the temperature. Oh, temperature increase. So we're using this kind of reason thing. Right? This kind of reason thing. All right? What happened to temperature? What kind of system? Okay? So temperature increase. So number 4, temperature increase Oh, what kind of system? Oh, exothermic system. Oh, temperature increase, that means you get me clothes. Exothermic meaning I want to take away my clothes, right? Temperature increase, you want to give me clothes. But exothermic meaning I want to take away my clothes. Oh, I want to take away my clothes, but you keep me clothes. They are not matching. So I'm not happy. Okay, so it's not favorable. So if you want to write down the reason thing, just like follow the thing here. A temperature increase in exothermic, not favorable. So temperature increase in exothermic, not favorable. Right? If it's not favorable, I will shift to the reactant. Right? Not favorable, I will shift to reactant. Right? Not favorable, I will shift to reactant. Okay? So because we shift to reactant, that means you want to shift to the left. All right? Now let's look up temperature decrease. So now temperature decrease, right? Temperature decrease, again, I'm on exothermic. So what happened? Now temperature decrease, that means I want to take away my clothes. Oh, exothermic, that means I also want to take away my clothes. So I'm exothermic, I want to take away my clothes. Now temperature decrease, now you want to take away my clothes. That means they both match. That means it's favorable. Okay, so it's favorable. Right? So if it's favorable, that means you want to go to product. If you want to go to product, that means you want to go to the right-hand side. Okay? So this is exothermic. Now let me shift to the... Okay. Now let's read this question. Okay. Now the delta H is not part of the reaction. You said there's no plus sign, but this delta H is 92 kilojoules. So first of all, we want to decide, oh, this is a gas system. Yes, it is a gas system. It is. And number two, what kind of system it is? This is endothermic. Oh, why is endothermic? Because the delta H is positive. Right? Because if delta H is positive, that means I am taking in energy. So what's endothermic? Because delta H is positive. Right? Why is endothermic? Because delta H positive. So you have two things to decide. One is a gas system or not. One is endothermic or not. Right? Exothermic or not. Okay. So now we can look it up. Oh, number 3. Temperature increase in endothermic. So temperature increase in endothermic. All right. So temperature increase, that means you keep me close. Endothermic, that means energy is entered in. That means I want to put my clothes on. Oh, endothermic meaning I want to put my clothes on. Now you increase my temperature, you keep me close. So they both match, right? Keep me close, put clothes on, I'm happy. So it will be favorable. Okay? So if it's favorable, it will go to product. And also again, this reason thing, they're all on here. They're all on here. Right? So temperature increase endothermic will be favorable. Okay, so if increased temperature in endothermic is favorable, that means I want to go to product. If I want to go to product, that means I want to go to the right-hand side. Okay, now temperature decrease. Now temperature decrease in endothermic. Right? Temperature decrease in endothermic. So what does that mean? Now endothermic meaning again heat is coming in. That means I want to put my clothes on. Now you decrease temperature. You decrease temperature. That means you take away my clothes. Now I want to put clothes on, but you take away my clothes, so I'm not going to be happy. So it will be not favorable. Okay. If not favorable, that means I want to go back to reactant. Not favorable, I want to go back to reactant. Okay, so if I want to go back to reactant, that means I want to go to the left-hand side. All right, so I hope this will help you.